My previous Dalek build had a skirt section made from fiberglass. I made a mould from an existing skirt section I acquired that was originally built for a new series Dalek. That mould was then used to cast my own fiberglass skirt for my 60s Dalek. Aside from their authenticity, fiberglass skirts have a number of advantages. They are very light, easy to sand and finish, and when you have the moulds they are quick to produce. The disadvantages are needing to produce a mould, having to finish and paint the surfaces, and finding fiberglass strands in your socks for the next 8 years. I wanted to replicate the feel of a fiberglass skirt but built from aluminium, including the push-through hemispheres. Although this time I didn't want such noticeable gaps around the hemispheres. So this was the plan: split the skirt into 3 side panels, a top piece and a bottom piece. Taking inspiration from user Aaron Tam on the Project Dalek forum, I decided to split the skirt at the front and 2 rear corners. That should leave 3 similar sized panels that will fit in my car, and it also means the sharpest corners are where the joints are. I have a friend from work who's good at welding and has a MIG welder that can do aluminium. So, I am to prepare the parts so they fit tightly together, drive to his workshop in Gloucestershire with the pieces along with my video camera. He's going to give me a quick crash course in welding, and with his help we're going to weld the parts together. Then I'll bring it all back home and finish off cutting the holes for the hemispheres. Job done. So the first job is to figure out what size sheets of aluminium I need to purchase. To do this, I drew out the flattened panels in my CAD package and stacked them together as they would be on the sheet of aluminium. I then drew a bounding box around the complete panel with a few millimeters extra clearance to account for measurement errors. I ended up with 2 sheets of 1100 by 780 millimeters and 1 sheet of 870 by 730 millimeters. I happened to get my order from Metal Supermarket, as they have a store less than 10 minutes away from my house, but sheet aluminium can come from anywhere. I actually ordered my metal in store, so 1050 was the only grade available to me. I went with 1.5mm aluminium for the side panels because I was worried about trying to fold them. To get a ballpark figure of the price of the sheets, I entered them into this online order form, but I think they worked out slightly cheaper when I ordered them in person. Still a fair amount though. Not that I'm trying to endorse them at all, but one of the other reasons I went to Metal Supermarkets is because they have fabrication facilities. I ended up getting them to fold the sheets after I cut them down to the right sizes, although they completely ignored the angles I wrote down and just bent everything to 45 degrees. I paid about £40 to get all the bends for the skirt done. The top and bottom pieces can be cut from the same sheet, as the top piece fits within the bottom piece. I based the dimensions on the outline of the skirt bottom plus some clearance. I originally went for a size of 1050 by 800mm as shown here, but I think in actual fact getting a sheet 1 meter wide ended up the same price, so I did that instead. I ended up going with 4mm sheet for the top and bottom pieces, as anything thicker was just too expensive. This is the only crappy bit of footage I have of collecting the sheets. I had laryngitis when I collected those, so I just spent the last 20 minutes being laughed at. As I don't have a printer big enough to print out templates, I needed a way of being able to measure out the pattern onto the sheets. I decided I would use the technique of intersecting arcs to determine the relative position of each point. So I needed a set of drawings that showed the distances between panel corners. I used the measurement tools in Cinema 4D to measure my model. The actual model I used is ever so slightly asymmetrical, so here are some rationalised values rounded to the nearest millimetre based on the skirt from the Project Dalek plans. So my starting reference is the straight edge at the bottom of the largest panel on this section. I can use the pre-cut edge of the sheet as a straight edge. Every other point is taken relative to that. I'm pre-measuring out some of the points on my makeshift compass. I'm using a drawing pin as the pivot for the compass, as it is able to bite into the surface of the aluminium so it doesn't slide. I found it easier to draw an arc with a biro than a pencil. Pencil either rubs off or doesn't show up. Where the arcs intersect is the corner point of that panel. The line between panels was made wider with a thicker tipped permanent marker. This is to account for the bend radius of the metal, as this is the internal surface of the sheet. Each subsequent panel is measured from the outer edge of the thick line rather than the middle. I used my 3D model to work out an average bend angle for each joint, which was a complete waste of time as they just bent to whatever the hell they liked. This is my first attempt at trying to use an angle grinder to cut sheet metal. Not convinced it's a great idea with aluminium, and I quickly changed to using a jigsaw with a metal cutting blade. I made sure I cut a couple of millimeters outside the lines so I could file the edges back when the skirt was assembled. There we go, that wasn't too bad. Well, I don't have any footage, but by this point I'd got Metal Supermarket to overbend my skirt panels, and I had eventually wrestled them back into the correct angles. The side panels are just held together with sellotape. Rather than just draw out the skirt pattern from the plans or my 3D model, I thought if I offered up the real skirt it should be a better fit. It's not really obvious in this footage, but somehow I managed to make my first major mistake here. At some point the skirt is moved when marking out the skirt bottom, so when I come to cutting that section out it no longer fits. So this pretty swiftly killed my cheap jigsaw, even with a metal cutting blade. 4mm is too thick for it. The jigsaw broke on a Sunday afternoon, so I couldn't just go and get a replacement as the shops were shut, hence trying ridiculous ideas to try and not waste the evening. I still can't believe how well a handsaw worked on cutting aluminium. It just goes to show how soft a metal it is. I got there eventually with a handsaw, but it did take absolutely ages. So the next weekend we have a new jigsaw and we're cooking on gas. So it turns out this jigsaw has an adjustable pendulum motion for the blade rather than just straight up and down, and that helps it cut through the metal better. Fascinating stuff. So this is where it all went a bit tits up. Aside from a couple of failed attempts at stick welding, I'd never actually welded anything before. The plan was my friend was going to help me weld the skirt together. Well, life happened and he couldn't get to his workshop for a few weeks, so as a compromise he lent me his MIG welder for the weekend. So this is me, with an hour's CO2, an hour's argon and 18 seconds experience, trying to remember what I've seen on YouTube. I thought I'd try practicing on some steel first to get used to welding, which to be fair, at least vaguely worked. So after that I'd try moving on to some offcuts of aluminium, get the settings dialed in and go on to tack the skirt together. Then I'd try running some beads if I had enough time. Here I somehow generated a big arc that melted the gas shroud and broke one of the copper tips. I didn't anticipate just how difficult it is to see through the welding mask, even though this is one of the ones that automatically darkens with bright light. To be honest, I'm still too ignorant to even be able to critique myself. Once I'd done a few beads that looked feasible, I decided to switch the gas over to argon, change the reel of wire over and have a go at welding some aluminium. At this stage I didn't have a manual and no idea, so I just tried playing around with the settings to see what kind of effect they had. This is the first of many times the wire got bunched up. The aluminium wire is soft, so if something stops it feeding through the torch it quickly gets tangled and has to be cut out. This is why you'll find most welders use a spool gun when MIG welding aluminium. In this instance I produced too big an arc again and it melted the wire back into the tip and clogged it up, so I had to replace the tip and refeed the wire. This happened about 20 times over the period I spent trying to weld the skirt. Speaking to my friend, it seemed like my wire feed rate was way too low, so once I bumped that up it at least started to penetrate into the sheet metal. By this point I was close to running out of gas. I had a couple of successful welds, so I thought sod it, I'll give the real thing a go. About here is where I ran out of gas without knowing, listening to the footage back. Therefore from here on in I was on a hide into nothing. I found it too difficult to keep the skirt stable on its side, so I moved it down to the floor. These welds weren't penetrating at all, but they were just about holding the panels together, despite looking like crap. I stopped here for the day and had to return the welder. Rather than rely on my friend, I found the exact same welder for only £300, and, at this point believing it was still possible to weld aluminium with it, I bought my own setup. As it happens, I never really got any good welds out of it at all, even with a full bottle of argon. The only couple of times I got good penetration, it burnt straight through and left big holes. I got to the point where I just had to conclude that I'm not currently capable of welding this skirt together, and if anything I'm potentially ruining what I already have. I'll give welding another go again when it comes to the shoulder section, but I'll make sure I get plenty of practice in first. But for now, time to cut my losses and go with a different tactic. I decided to try using these small brackets to attach the top and bottom pieces to the side panels. I was hoping that if I used countersunk M4 machine screws they wouldn't be too noticeable against the aluminium sheet. Once I had secured the top piece, I had to go round all the screw holes again and countersink them. One job I still have to do is to go round and replace all the nuts with nylock nuts so they can't shake loose. When I welded the top panel I didn't realise it hadn't sat flush with the top of the skirt, so I had to trim the skirt down a few millimetres using a hacksaw. This made the most unbelievable racket, which I won't punish you with. Then it came to trying to fix the misshapen bottom piece. I didn't have another large piece of 4mm aluminium, so I had to cut up what I had and try and reattach it together so that it fit properly. I may go back and replace this piece in the future. First step is to mark out where the holes for the hemispheres go. For the single column panels I'm drawing a line down the middle. For the double column hemispheres I've gone for a Mark 1 arrangement. This means that the top of the panel is divided into 4 and then a line is drawn from the 25% and 75% marks parallel to the edge of the panel. I marked the vertical position of the hemispheres based on the Project Dalek Mark I plans. To do this, I marked out a single panel and found something that sat my marker pen at the right height and rotated the skirt around. To cut the holes, I found a 100mm carbide hole saw for cutting stainless steel on Amazon. I went for 100mm rather than 4 inches as I wanted a fairly close fit to my hemispheres when pushed through from behind. Cutting these holes needs quite a lot of torque and there's quite a long cutting time. As a result of that, it managed to kill 2 battery drills and 1 cheap mains powered drill, before I finally bought a mains powered drill with better speed control that managed to finish the job. This hole saw did have a tendency to snag, so quite a few of the holes have mangled the surrounding aluminium surface. This represents many days of work to cut these 56 holes, but it is at least starting to look the part. The joints between panels had started to split due to the force of the hole cutting. I used beads of epoxy putty like chewing gum to hold the backs of the panels together. This stuff sets like stone. I tried seeing if I could use aluminium powder and epoxy resin to fill any gaps, hoping it would look similar to the existing metal, but it has come out looking way too dark. I think I'll touch it up with a paintbrush and some bright silver paint so it doesn't stand out too badly. Once all the gaps had been filled, it was time to file all the edges of the hemisphere holes and sand back the whole surface of the skirt. I would love to have kept the clean finish from when the protective plastic came off, but it was already too tarnished to polish out. I gave the whole skirt a final pass with 400 grit wet and dried paper, and then had to call it a day for Christmas. By this point I'd worked on this skirt section almost every weekend for 4 months. It was time to stash it away in storage and finish buttering it up in the new year. Jeez, I think I need a haircut. Thanks for watching the video. Sorry it's taken me so long to get it out. As you might have guessed, it's taken me a hell of a lot of time, not only to film that video but to edit it. So let's hope for my own sanity, if not anything else, the next one's a bit better. If you got any kind of value out of this video at all, I'd really appreciate a thumbs up. This has killed me, both emotionally, financially and physically. So thanks very much for watching. Take it easy.